All right, this is the in-class graphing assignment that we did. I'm looking at number 2. I can tell it's a rows because there's a number in front of my theta. And remember, when there's a 2 in front, that means we're going to have double the amount of rows petals. That's where I'm getting this 4 petals from. If it's a 2, it's doubled to be 4. If it's just a 3 in front of your theta, it just means it has 3 petals. The symmetry talks about what trig function is being used. Since it's a sine function, we're thinking sine means y, so it has y-axis symmetry. To find our maximum, okay, to find our maximum, think we are plugging something in here for sine 2 theta. So what number could I plug in there for sine 2 theta that would make this as big as possible? Okay, and your choices, remember, are 1 or -1 because sine functions fluctuate between 1 and -1. So -5 times what? -5 times -1 is going to make this a positive 5 for my maximum. Okay? That's great, but now we need to answer where does that happen? To answer that question, we are using this information right there. To make this as big as possible, we said we want sine of 2 theta to be equal to -1. That's where we said it became the biggest. So remember, we need to solve this now. We're trying to get theta by itself. So what do I need to get rid of? Well, I need to get rid of sine. So technically we are doing inverse sine, which means to us, where on my unit circle is y -1? So I think about it, y equals -1 when theta equals 270 degrees. That is not the answer to my question. That's when 2 theta is 270. I want to divide by 2 to get theta, to get the answer at 135 degrees. That is the answer to that problem. My angle is 5 at 135 degrees. So if I go down to my picture down here, at 135 I should be at the 5th ring. Okay? Then, when it's a rose, understand what you're graphing. Hey, it's a rose, it has 4 even petals. Okay? So I'm going to have 4 different maxes of 5. Okay, to decide when those maximums are going to occur, think about what you have. Okay, this is a circle. It goes from 0 all the way around back to here, which is 360 degrees. Okay, so use your brain. Hey, 360 degrees, and I need to split it into 4 equal petals. That tells you that each petal is 90 degrees apart. So every petal that we make on our picture here is going to be 90 degrees apart. Well, I know where my first one is. It's at 135 degrees. Okay? From there, I'm going to take 135, and I know you don't need this, but I'm just showing it, 135 plus 90 degrees. That's when my second rose petal is. It's at 225 degrees. Great. Well, my next one is 90 degrees apart again. So I'm going to add 315. I'm going to add 405, but I'm going to be a smart math student and say, oh, 405. That's more than 360, so to decide when that is, subtract out that full ring of 360, and it reminds you to have 45 degrees for my last one. Okay, so let me zoom out. Those are the different things I'm graphing. Let's put those on our graph. So 135, 225, 315, 45. They look evenly spaced out, and they should, and we know we're going to touch the center. It's a rose, so in general we know what the picture is going to be, but if we need to graph it, we can. It was -5 sine 2 theta, so -5 sine 2 theta. Oh, I am not in the correct mode, sorry. Perhaps I should be in polar. And I'm going to need to change my window, just like always. So -6 and 6. Let's try this again. Y equals -5 sine 2 theta. Close parentheses. Let's graph it. There's my rows. So it's going to go There it is. Not perfect, but you get the main idea there of graphing it. Doesn't have to be a perfect picture as long as it resembles a rose with 4 petals. You're good to go.